Yeah, you are welcome to class today. Today we are going to be looking at dimension in physics. We're going to be looking at dimension in physics. Today being the 24th of April 2026. Dimension in physics. Dimension is actually like the dimension of a physical quantity indicates how a physical quantity is made up in terms of the international system-based quantities. Now, what we want to look at is now we can use dimension to check whether a physical equation is correct or not. We can also use dimension to derive the exact form of a physical equation. Now, today I just want us to look into this particular question. We want to see we want to use dimension to check whether this physical equation is correct or not. We want to use dimension to check whether this physical equation is correct or not. Now this one, S is equal to, let us define or let us know our parameters. S being distance and U being initial velocity. This is initial velocity, and the A is our acceleration. A is our acceleration, and T is our time. Now, to check whether this physical equation is correct or not, if it is correct, then each term, the dimension of each term will be the same. The dimension of S will be the same as the dimension of UT and will be the same as the dimension of AT squared. So how do we go about that? For S, in dimension is actually we consider three basic quantities, which is length, time, and meter. Length, time, and meter. So if you look at this, S is distance, and distance is measured in length. So we have L. For the dimension of S is equal to L. Now for the dimension of UT, we know that UT is our initial velocity. All right. And what's the formula for initial velocity? The formula for initial velocity is distance over time. So, and we also have time here multiplied by t. So distance over time. So the dimension will now be, since the dimension of distance is equal to L, then we have t multiplied by t. So if you look at this, we can calculate this further. This t, we cancel this t. We have L. So the dimension of UT is also L, which is the same as the dimension of distance that we have here. So for AT squared, or the formula of acceleration is velocity over time. Velocity over time taken multiplied by t squared. Which is equal to the dimension of velocity is LT. Since we have, that the velocity, initial velocity, dimension of velocity is equal to L over T. All right. So the dimension will now be LT is for minus 2. If you convert this one to if we can write this one as this. So LT I'm coming. L t raised to power minus 2 over t multiplied by t raised to power 2. Now looking at this now, we can actually solve this further. L t raised to power minus 2 over t times Lt raised to power 2. So we can solve this further. Now looking at this, we can say that Lt okay, this is Lt raised to power 1, not Lt raised to power minus 2. Lt raised to power 1, Lt raised to power minus 1, sorry. So we have this. Then we can say that Lt raised to power minus 1 over t multiplied by t squared. Okay, so we have this one cancel out these. We are going to have Lt raised to power minus 1 multiplied by t. Now since you have this, when you use, we can say that Lt raised to power minus raised to power minus 1 plus 1, and we know that this one is Lt raised to power 0, because minus 1 plus 1 is equal to 0. So then this will now be is equal to L. So the dimension of, so we have L now. So therefore S is equal to UT plus 1 over 2 AT squared. In dimension, you don't, when you are using it to check whether the physical equation is correct, you don't look at the numbers that are there. You don't look at the numbers, you just work on the alphabet, the notion of the parameters that are there. You work on the notion of the parameters that are there. You don't look at this 1 over 2. So you have S. For S, the dimension is L. For UT, the dimension is L. And for AT squared, the dimension is L. So therefore, equation S, therefore, the physical equation S is equal to UT plus 1 over 2 AT squared is dimensionally correct. So therefore, this equation is dimensionally correct because each term has the same dimension. So S is equal to L, UT is equal to L, and AT is equal to AT raised to power 2 is equal to L. So the equation is dimensionally correct. It's very correct. All right, thank you. If you have anything to drop, just drop in the comment section so that we can look at it together.